Welcome everyone to today's video. Today I wanted to show you another nice piece in my collection. In the meantime, you may think I'm a total crazy hoarder here, but actually that's not so much true. As I said in yesterday's video, I think 20 systems are enough, and I think I do not have so many more than like 20 systems. Usually such outstanding systems have a reason why I have them. This is a OQO, or however you want to pronounce it, OQO. OQO, whatever, 01 Plus. Like many other pieces in my collection, I did not purchase this one new because at the time I was likely a student or something or started my company. In either case, I did not have any enormous amounts of money to spare, and this device was quite expensive, $2,000 or something, and there was no way I would shed so much money onto this. What is it? This is a fully functional tablet PC in a size slightly larger than a personal digital assistant PDA. According to the Guinness World Records, the OQO was the smallest full-powered, fully featured personal computer in 2005. And the reason I got this is not even mostly for this, but it's powered by a Transmeta Crusoe CPU, and for my T2 Linux distributions I tried to have a different few processors around just for fun. Even before university I read about Transmeta and I always found it interesting. So the next thing is, what is Transmeta Crusoe? Transmeta Crusoe is a x86 CPU manufacturer that you may have not yet heard about. Instead of regular processors that work like normal processors do, taking a number, interpreting it like it's an add, multiply, jump, compare and so on, and do the dedicated function, this processor is a very large instruction word processor, and it's not x86 compatible, so it's not using the same numbers to perform additions, multiplications, jumps and such. It is using entirely different instructions like PowerPC, Spark and such, but it's even different than PowerPC and Spark in that it's a very large instruction word. So these are 128-bit instructions, and these very large instructions perform multiple instructions in one, like adding a value, subtracting another value, comparing another value. And certainly they were a way that they could not easily sell an x86 incompatible processor. So what they did was they developed a code morphing software that, like just-in-time compilers today, translates this x86 machine code numbers into this very large instruction word architecture. And you can really run a normal x86 Windows or Linux on this, and you do not even see at all that this is using internally a non-x86 instruction set. Really fascinating. Transmeta was founded in 1995, and even at the time they employed Linus Torvalds, maybe for having some operating system knowledge and guidance and testing and feedback, something for implementing this code morphing software. I was reading articles of this design and find it highly fascinating. These were also ultra low power and had dynamic frequency scaling and voltage scaling. I think these were one of the fast consumer processors that used those features, and also infamous thermal design throttling. While their processor was not the most successful, they licensed this frequency scaling and voltage scaling and such to other companies, and soon including maybe Sony and Toshiba or something for the P3 or so. I probably already talked too long in this video about this. Maybe I make a dedicated video about this fascinating processor. And the reason I got machines like this is I wanted to have one sample of this processor. I got this 8 years or so, of course used, and I was totally lucky. I only paid 110 British pound. And it was nearly unused. It only had slightly discolorization. Here also the stand. I think the seller said something like window presentation marketing unit. They probably had a hard time selling this. I think the price was something like $2,000. And I got the Plus model because the Plus model has double the memory. The initial OQO model 01 had only 256 megabyte of RAM, and the Plus model has USB 2 and 512 megabyte of RAM. This is why I wanted this one, and I'm pretty lucky that I got it. As I said, this is a total tiny PDA-like tablet PC thing with full keyboard. In a way amazing, even more feature-rich than an iPad, because it comes with a keyboard that you need to pay Apple additionally for. Also a track point like ThinkPads, and the keyboard obviously is this A rubber sync keyboard is slightly unergonomic to type on, but when I got it new, it was totally disgusting experience, but you get used to it. So I don't use it often, like I test T2 or something once a year, or I need to charge the battery, like today, although it's still quite full. This is also a thing with collector items like this. If you want that the battery stays a little bit usable, you need to make sure not to discharge it too much, like taking it out in storage, and also charge it sometimes. And aside from this, it also has pen input. So it comes with a 1 GHz Transmeta Crusoe processor, 20 gig hard drive, although I think I swapped this out for an SSD. Initially 256, so this Plus model 512 MB of memory. The initial model USB 1, this Plus model USB 2, and surprisingly Firewire 400 here. A headphone jack that even Apple cannot get into latest tablets anymore, and Wi-Fi and Bluetooth. And these are the antennas, really funny that they have them visible outside with this plastic shield there. And I think this was a speaker, maybe this was a speaker, and here comes air out or something like this. And also a jog dial for scrolling and such. Really interesting, funny design. The small screen is 800 by 480 pixels, and it's some transflective screen. When you buy things like this, you often have other drawbacks. So for example, the battery was completely dead. I had to open it, which I will not do today because already this snap-in noses break off inside here. So I reanimated this, I opened this and pre-charged it with a lap power supply like this, because obviously a total dead lithium polymer battery will not be charged by the built-in charger. And also later I realized one of the soldering joints was broken. Inside here are these battery cells with flat plastic flex cable, and I soldered this back together again. So this is the back side, and I think there also was a twice as big battery pack. This one only has 4000 milliamp hours. Certainly not for the greatest battery life. And also these power supplies were prone to fail, so I got it without a power supply. So I had to figure out this pin out here, also from other people blog on the internet. So I personally only ever charged it with lap power supplies. And here it came with a stand. It also came with this docking cable, which I find rather fascinating as well. Actually not such a bad idea. The concept is that you plug this multi-connector thing in here. This is, by the way, the power plug, and this is USB and Firewire. So this just plugs in here. And then you have a cable to the back of your desk where you have not only the power, where I need to connect my lap power supply, but also USB, headphone jack, Ethernet, which is obviously USB Ethernet, and VGA, surprisingly a direct plug, and a connector. I wonder how they do this with signal integrity. Maybe it's not featuring the highest resolutions. Surprisingly, it has a dedicated graphic chip, but an Silicon Motion SM720 Lynx 3D Plus, where there is an open source driver, but only 2D and not the most amazing. The official maximum resolution is 1280 by 1024 or something, but I think I drove it with Linux driver at least at 1600 by 1200. Somehow that works, although even the specification does not specify this for this chip, but somehow it works anyway. Actually, surprisingly, this time the battery is still full, which in previous years it never was. But first of all, last year I soldered this battery cell, and also this year I took it out for storage. And also the internal battery for the real-time clock is dead, and this is soldered, so I'm not sure if in the future I will solder a new RTC battery in there. Coming back to the charging procedure. So this needs 2 voltages. So of this 5 pins, 2 are ground, 2 are main supply voltage 5 volt, and 1 is charging voltage, which according to others people blog post was 6 volt. Not sure if that is true, but this is what I'm using. So far I've not damaged it. And as I said, I never had the original power supply. This is also why I don't have the original plug and need to use this wiring stuff here. And I do it the following way. I use a universal laptop voltage charging thing here, plug the wires into this here with 5 volts, and then I use a charging voltage from a lab power supply. So let's hook up my yearly charging procedure. Then I use this banana plug things here to plug this in together. The problem is it's already slightly destroyed, probably by procedures like this. So then when you have nicely clamped in your ground there, and you make sure all your pins are still in there. First of all, you also need to connect your ground. We do this today. And this will be charging voltage on this pin. And then you need to make sure that you use the right polarity here. So we plugged in positive in the center. Center is here, so positive to that. So that should work for today. I wish they had sent me the power supply even if defect, but maybe they used a defect power supply to repair another one. So let's boot it up, and also this is maybe press F1 for empty BIOS battery or so. Of course FN is here, FN with F1, F2 and such. So in the meantime, quite some kernels there. As I said, I have this already for quite some years. Of course it's not the most fast, but it would be quite usable as a thin client or so. Although it's with the code morphing, obviously not a performance breaker there with 1 GHz code morphing and such. However, the reason I'm currently not using it as much as I could for some secondary email screen or thin client or something is that since quite some years there's a kernel bug in regards to interrupt or timer handling, and I did not yet have the time to take a look on this. So it works, but mostly USB and sound is quite messed up. So if you use a USB keyboard, not all key presses will register. But again, this is not a problem of the unit. It doesn't happen like this in Windows. Like Windows XP as still test installed here for dual boot testing. On Linux it's kind of unusable with kernels of the last 8 or so years. And also sound is totally messed up in Linux. Also in Windows it's fine, although the headphone output has not the most audiophile properties, but at least on Windows at least can listen to music. So this is an UK keyboard, so proc. So you can see you can type on this. As you can see there on the not most angle stable transflective display there, Transmeta Crusoe processor TM5800 with a whopping 0.5 MB cache, and also only MMX and not SSE. Pretty neat. And now we also want to charge it. So for charging, let's plug in here our power supply and hope nothing burns through here. So cut /proc ACPI AC adapter state is offline. Let's plug it in and hope nothing bad happens. And now we are online. But in this state, as you can see, it's not charging because we do not apply the second charging voltage there. So the only thing is the cable is not super flexible. And obviously right now we have our charging stuff wired up there. So let's plug in also our lab power supply. With our lab power supply plugged in. So this lab power supply does not apply output voltage. It is here, output is disconnected, but always nice double security to pull it out. As I said, the charging voltage should be 6 volt, at least according to other people. And don't sue me when your OQO burns through. And we can also, okay, right now it's quite limited. Okay, maybe we start with 0.5 amp. and then we connect it, and boom, we have, of course, current limited, and we are charging, as you can see. And I documented this also on my blog, I think, because the other blogs and information are already bit rotting on the internet. This is why I already documented it myself, a copy for the future. So what are we getting here? We still constant current limited there. So as you can see, the charging voltage here for this lithium ion is quite hefty. So this is still current limiting. So right now we are charging with 10 watts, which is of course quite some power. I always find this pretty amazing, this integrated circuits, how much current goes through there. Yeah, this is a yearly charging procedure to make sure the battery works at least a little bit. And as I said in earlier videos already, I also make these videos not only to show you miniaturization marvels like this, and this kind of outstanding pieces is exactly what I'm collecting. I'm for the most part not collecting random nonsense, only such outstanding achievements like this. And again, I also personally find it pretty interesting, this code morphing software. Although it did not have the highest performance, it was quite energy efficient, at least some sort, and I find it still interesting to have. By the way, was this maximum brightness? Brightness was mute. Here's brightness is this, FN, this I guess. Yeah, this was already maximum. Again, displays of this area, not the highest brightness. Yeah, ideally I would want to hunt this regression and make latest kernels run great on this again. As I mentioned in other videos already, I want to build this community and use this YouTube ad revenue and such to invest this time, because just unpacking this, as you can see, this is already 15 minutes getting this charging going, keeping this working, and already put quite some time into revitalizing this battery, figuring this charging out, because initially it was not charging. And also initially I used only 6 volt for everything, and I think this made this OQO run hotter. I think the power regulators inside here for the 3.3 and 1.8 or whatever voltages run way hotter with a higher input voltage. So this is why you want to probably run this dual voltage with 5 volt for the regular I/O stuff and 6 volt for the charging stuff. Otherwise you overheat the OQO. I hope you like this dive down the memory lane for outstanding vintage computing stuff. Like, share and subscribe for this presentation of vintage computing history. And now, where is my VGA cable? For what did I use VGA recently? We could plug this directly into the display, but I don't want to throw my coffee over while fiddling with the cables now. Then USB, and also, so this goes there, should give us, yeah, as you may be able to see if we are lucky with this viewing angle. So the USB problem is that sometimes it doesn't get key presses and repeats keys multiple times. So as you can see now, I don't type anything anymore and it didn't get the key release there. And as far as I found out, this is some timing and interrupt related, or mostly timing related. I already fiddled around there with TC, stable, unstable, and timing sources and whatsoever, and different older kernels and such. And other users did not have this in the past 10 years ago with old kernels. So I guess it was working back in some day, but I have not yet booted an old enough kernel. It is usable, but it is completely annoying. Like now, this repeated there, totally annoying. And the sound is totally messed up due to this, I guess. And let's start X. Maybe I even had a René user. Yeah, no, it repeated enter there. As you can see, this certainly is super annoying. But again, other people used this a decade ago, so as you can see, the window movement refresh speed there is not the most outstanding. And yeah, key repeat. I find it amazing, however, that this driver, it's not a very popular driver, although I think it was used in some later OLPC maybe or something, or some other machines. And I find it amazing that it works at all so good, but of course it's not a high performance. Let's see, do I have here some sound files? Oh, I have here Tori Amos. Can you believe? Let's try to play here some big wheel. Let's see what happens. Why does it not 08? No? Nah, broken keyboard does not. Yeah, this is exactly, of course, it's not fun to type if every other key press doesn't work. Like now. Yeah, that's not the actual speed, this is going faster and slower, just as dynamic clock scaling goes faster and slower, so there's something not really working with this long run frequency scaling stuff. And networkers or beloved Ethernet cable. I think it's not a bad system, this docking cable stuff. So DH client, here. The funny thing is, of course, this keyboard does not exhibit this timing issue because this is PS2 or something. So DH client Ethernet 0. Here, I actually spent already some hours test booting all the kernels, and this is exactly the inspiration why I'm doing YouTube videos now, that in the future I hope you find this interesting and I can then also maybe live stream here some hours of kernel hunting and isolating which kernel change in the past made this break, maybe some high resolution timers or maybe even frequency scaling related stuff. And so subversion up here in the T2 tree will get quite some changes for quite some year or so. And let's see, can we type while we do this with this broken USB interrupt handling? I think some king speed or something. KSD CF 100, what's it, 128 gigabyte or something. Yeah, quite some big thing. I hope it lasts some years, as others wrote at Amazon or something that they fail rather quickly. I sure hope it doesn't fail quickly because it's an 1.8 inch SSD, I think, or something, tiny at least. Yeah, I think 1.8 inch. And the only thing is, if you use it, the fans start to spin up quite a bit. But I nonetheless find it a pretty amazing piece of technology. I also once used the Firewire, so the Firewire works, and I think I once backed up some G4 Cube in target disk mode or something on this OQO 01. So you can really use it at all, and on Windows I even used AutoCAD, the AutoCAD 14 from 1996, which is of course crazy how lagging latest software became, that on such a low performance machine, 1 GHz code morphing, you can run a vintage version of AutoCAD. I once layouted a bathroom with it some 7 years ago, and of course in 1996 at work we had a 200 MHz Pentium Pro, and of course this gigahertz code morphing, let's say the code morphing can be slow and you get at least half of the performance, often of course more. It is still way faster with 500 MHz equivalent or more than a 200 MHz Pentium Pro, and such a tiny machine can run AutoCAD 14 without problems. Totally kind of amazing, at least usable. And if you run something modern on this, of course it's crawling like a dog. So subversion updated, and battery charging still getting warmish, still pushing over 10 watts in there. Still current limited in the current setting. I think we can get higher. Yeah, now it's constant voltage, and yeah, somehow the voltage there is often higher. Anyway, sometimes you need to make sure you use the batteries a little bit, otherwise they become totally dead. But I'm nonetheless lucky that I could revive it, because as I said, when it came it was totally dead, and only with pushing some electrons in there. And also soldering the broken connection, I could revive it in a state where at least now it's usable for at least some 30 minutes, or if I'm lucky 60, especially if you don't use it so much. So again, I hope you liked this. Stay tuned for more things like this coming. And the nice thing is, as you see, every now and then I use these machines, and I would use it even more with more usable USB. Could, of course, with this docking cable, use it as a thin client or such. Totally no problem. Even do light code editing on it and such. Totally no problem at all with Linux and so. And my T2 system, testing real 32-bit systems. A pity that this needs some regression hunting, but that's what we are here for. Actually, if you have worked at Transmeta or Silicon Motion, or what this was, SM Silicon Motion, I think, 720, Lynx 3D. If you worked at companies like this and have some internal documentations laying around, I would really love to hear for you. There are some public register specifications for this SM720 Lynx 3DM, but they are not complete. 3D parts is mostly missing. We could also, in the future, just for fun, write a 3D driver for this, because I think the only 3D driver commercial, but only for this from the company, were for Windows 95 or so. So even for Windows 2000 and XP, you don't have a 3D driver, which is of course very ironic, because I think this shipped from the factory with Windows XP Tablet Edition, and this factory installation did not have a hardware direct 3D driver, ironically. So you could only ever use 3D with this chip, as far as I found, with Windows 95 or so, which is of course totally ironic or something. Yeah, would be cool to do this, but in general, of all of my videos, if you have inside knowledge that you want to share, always feel free to contact me. So hope to see you soon for the next videos to come. Actually, this Windows movement timing may have been USB related. As you can see over the PS2 track point here, no problem. Also, I resized there the output, just as I remembered. At least 2440 by 900 is possible. As you can see, matches this 16:10 image there of the display pretty nice. So no problems whatsoever. We only need to fix USB timing for the USB keyboard to be awesome.